Okay, we're at Thursday of week 6. Time is flying. Just as sort of a pacing note, we will probably finish saving for retirement not today, but on Tuesday of next week. And if it takes us more than 2 days, that's fine. We're not in a rush. That would mean week 7, we start business decisions on Thursday, finish it up at the beginning of or end of week 8, and then all of week 9 and 10 we'll have review, and we'll do more stuff with the big issues and the book reports and stuff. We'll have time in class to deal with those. So if you're feeling a little behind, good, that's on purpose, so you actually get them done. But don't panic, because we'll make some time in class. Okay, before we do more saving for retirement, were there questions people had on any homework they tried, or they were following the lecture at home again and couldn't do an example problem on your own, or anything like that? Okay, well, let's do a little review anyway. Not with percent sentences, we've done that a lot. We have a new picture. So I tried making some cute, clever things and couldn't. I wasn't sure if I did the right thing. Tuesday, sharing something that was dysfunctional, saying this was the best I could do, maybe you could make a better one. But what I did do is make a nice picture. So we have a whole amount. We have a part, which in this case looks smaller than the whole, but remember that's not always true. And then we have how much that part is expressed as a percentage. And then we can always make a percent sentence where the part, the change, the new thing, is a certain percent of the whole, the original, the baseline. So if that picture helps you, then now there's a cute picture there. And if you wanted to make those shortcuts, I've listed them out here, but I've given up trying to make some clever diagram out of it. Because as you saw, the more I tried to make it cute, the worse it was to use. So maybe you can do better, but that's what I have so far. Interest. We've talked about interest. We've done simple interest. Let's just do both of those random problems. So that sounds good to me.
Can we do the +1 thing?
Yes, I'm going to do them both ways. I should design this one so it flips back and forth and sometimes asks interest and sometimes asks total. That would be smart. I'm not going to promise that happens. Okay. A small business borrows a certain amount at 27% annual simple interest rate. It repays the loan after 112 days. How much interest does it owe? So very general, interest is principal times rate times time. For simple interest. Okay, and for simple interest, we always want everything to be in years. That's how simple interest is designed. Can't change that. So all of this is just sort of my mental framework. As soon as I see simple interest in the problem, I know that it's going to look like this on my scratch paper. If you've done a lot of these, you can skip my blue stuff. But for now, I encourage you put all this blue stuff because that's where the tricky stuff happens. If you jump right to plugging it into the formula, that's where people make mistakes. So the interest is what we're solving for. The principal was $3,000. 113. The rate is 27%. That's 0.027 per year. And the time is 112 days. Okay, what next?
Well, we have to change the 112 days into years.
Yes.
I didn't say that right, but
Not sure what's wrong with S's today. The computer is fussing. Oh, okay. Okay, so we're happy. Years, all of our fiddling is done. We're ready to plug things in. Now, I rounded just because I am needing to write stuff on the board. In my calculator, I'm not going to use a rounded number because I'd rather not round in the middle of a math problem. So I'm just going to take this big number sitting on my calculator, and since I can multiply three things in any order, I'll just start with that. And then I'll do the times 0.027. Whoops, I made a mistake. No one caught it. There's no zero. It's not 2.7%, it's 27%. Okay, so I take the thing in my calculator and multiply it by the correct number. And I get $257.91. Everyone else get the same. I didn't hit any keys, funny.
I'm sure I'm wrong, but I got 264.
Let's try again. So, times 0.27. Yeah, no, I got the same thing again.
I think I put the wrong number of days in the year.
Okay. Another thing we could do is say, well, I don't want to be tempted to round in the middle. So instead, I'm just going to take this stuff here and put it right there. So I won't actually bother to find out what that decimal is. I'm just going to multiply by 112 and divide by 365. And that works great. Get the same thing now?
Yeah, I think I put 356 for days.
So this way is nice because the formula has 3 spots to plug things in. You plug in 3 things, seems nice. This one is nice because you don't have to worry about what 112 divided by 365 is, because you don't care. That's just an intermediate thing. So either style has its virtue. Okay, the next problem. Okay, it is again simple interest, so I have to do years. I have the same framework I'll be working with. This one is trickier. So the interest is something I'm given, but indirectly. How much interest is it? How do I find out? Yeah, so she's writing a check for $1,222.88. She's going to some payday loan store, so she's post-dating the check, right? They can't cash it for another 12 days. And the loan is $1,113. So whatever the difference is, that must be the interest they're charging her. So what is that one? $22.88 minus 13, $9.88. The principal, which number was the principal? Yeah, the 1,113. The rate, that's what I'm solving for. And the time is 12 days. And as before, it has to be in years. So we're going to put a divided by 365. Okay, I don't want to do this one twice. So should we do the division, or should we just put both pieces in when we plug it in?
Isn't it 365 divided by 12?
No.
No. And then times it by, no?
So I had 0.0328, blah, 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 blah. We don't have to rip off or anything on it, right?
Nope, it's not. You're not making it in or out of percent format.
Oh, that's
so. Okay, Edwin's sort of right. You will eventually have the division the other way around. Okay, I think, since you don't care, I'm going to make a decimal out of this. And again, in my calculator, I'll just try to use what's in the calculator already. That would save me from him. Okay, so I plug things in. I have a number and the interest this time. Okay, I have two things stuck onto R with multiplying. So how do I do that? That looks kind of funny.
Is it like algebra? Times them both and then divide them on the other side with the 988 by it?
Yeah, if
Yeah,
something
R
is stuck
by
onto R with times, I divide by that thing to get rid of it. In this case, I just have to do it twice, dealing something off on each side. It doesn't matter if it's stuck on to the right or the left. It's stuck on with multiply, so I divide to get rid of it. It doesn't matter which one I divide by first, or you could even divide by them at the same time because you have a calculator. I'm going to write it in steps just because I'm lecturing. I'm doing this one first because that's what's sitting on my calculator screen, so I can avoid my rounding. My calculator has a button called Previous Answer. In this particular model, I have to do the green alpha button and then equals. So if I go 9.88 divided by the previous answer and then equals again, I don't have to type in that decimal. And now I have the other thing stuck onto R with times. So again, I will use division to get rid of it. Divided by 113. Now I finally need to riplop. Why does this decimal need riplop? Because somebody asked me for a percent. So I need to go right into percent, and I get 27%. I guess this is slightly rounded. The other problem had a 27%. I should check my JavaScript so I'm not giving the same percentage in both problems every time. Hopefully that was just a coincidence. Okay, questions on this? This is the most complicated algebra we've done this term. We had to divide to get rid of two things on the letter instead of one. But you can handle it. Everyone's good? Can't tell how much it's lunch and how much you're happy. Let's load up another 33. Yeah, it looks like it's always the same. That's no good. Okay, I'll have to change that. So that was the simple interest formula. Then we have the compound interest formula. And again, I think we need to review. You didn't ask for review, but I will give you review. And let's just do a problem. Before I start this, I want to just do the first 2 years manually as a review of why this formula is the way it is. Manually isn't quite the right word, but good enough. So he starts with 11,000. It's going to increase by 6% compounded monthly. Oh, I'm sorry, not years, months. Otherwise we'd be here all day. So monthly .005. My brain isn't off. Okay, good enough. So the first month, we have to take that 1/12 of 6%, 0.005, half a percent, and we multiply his principal by that, and we get $55 interest. So he gets some statement in the mail saying, congratulations, now your investment is up to $11,055. The next month, it goes up by half a percent again. We multiply by the 0.005. He gets a tiny bit more interest because he has more money. If we were starting month 3, it would be $11,000 and a little bit more than 110 because we'd have to add this onto that. Make sense? So that's slightly awkward. I don't want to have to add back the 55 onto the principal to get to the next line. I don't want to have to add back $55. This is money. Why am I having... Sorry. We're not a gas station. We can't use 10 cents. Okay. I don't want to have to add on the $55.28 for the year 3. That's just like something I might forget to do or whatever, right? So maybe there's a slightly better way to do this. And what we can do is say that what will actually multiply not by the 0.005, but a 1.005. And why would we do that? Because then my answer has 2 parts. It has the times 1 keeps the 11,000 around. That's saying that there's an 11,000 here. And then the 0.005, I'll change the color. That's the 55. And so I can add them together. We already saw that you take the 0.005, when you multiply that, you get your $55. 1 times anything is the same as it originally was. So we get both of them together. Similarly, if I have a 1.005 here, it's going to be nice. Let me move just that row down. Sort of. Then the times 1 is still the 11, in this case, 55. The 0.005 times that was our 55.28. And we get both of them. And that's again a second month total now, not just the interest. So if you want to do this, you don't have to use the 1 in front. The point of the 1 in front was that when I'm moving on to the next row, I have the thing I'm working with already. And if you remember from a few days ago, with this years of rent increases, that's where we got this pattern of an exponent with the 1 point something is what we're using the exponent on. That's because the same kind of thing is happening that we just did. We're saying, I'm taking the answer from the previous row, multiplying it by the same number one more time, which makes the exponent go up by 1. And then that gets me the new answer for the new row. So it's because we're trying to automate it, we're trying to move down to the next row as smoothly as possible, that we don't want the interest as our answer, we want the total. If you were just doing this for 1 month only, you could just add back on the principal and not do the 1 plus trick, and that's great. There's no incentive to make it efficient. But since we want the formula to move us down to the next row automatically, we have to do this. So that's what this was. This was saying that this bit here needs to go right there. And this bit here needs to go right there. It's like a machine that's sort of slotting each piece into the next as the assembly line progresses. Okay, so that's the pattern, and from that we got the formula. And we saw that you could have the formula in a very general way, principal times the 1 plus interest rate, with the rate adjusted to be per payout, which usually is divided by 12, and then the number of payouts that happen, usually how many months this has been going on. But not all compound interest situations are monthly, and if you wanted, you could just have different formulas for different situations. The monthly ones have a divided by 12 into years times 12. The quarterly ones, you'd divide the annual rate by 4, and there'd be 4 quarters each year with a payout. If there was weekly compounding, very rare, but sometimes it happens, then it would be 52s. So you could just think of it as different equations, if that makes your brain happy. Do you want me to use the ones that have the 12s built in for our problem we're in the middle of? Or should I write the more general formula?
I'd like to see the more general ones.
More general one? Okay. So I will... Actually, I have to write it. Okay. So what we want is, no, I don't want that. Copy that again. Okay, now let's really start this. So our formula was that our total amount is our principal times the 1 plus rate per payout and again that looks complicated. It has parentheses, a bunch of words and so on, but all that this is the 1.005 kind of thing we did, right? It's just a 1 in front of a decimal. So it's not hard to use, it's just bulky to write. And then up top is the number of payouts. Like anytime I'm approaching a formula, if I've done this a whole lot because I'm all caught up on homework and it's week 10 and I've done a zillion practice tests, maybe you can just plug things in and never make a mistake. But for now, we're going to write all the blue stuff because this is where the tricky things happen. Including trouble writing eyes. Okay. Okay, everyone okay with my setup? I haven't really started the problem yet. This is just sort of my mental framework. As soon as I see compounded monthly, I know it's going to have all of this stuff. I'm going to use it again, so I need to copy it. Oh, okay. Okay, now let's start reading. He invests 11,000. So the total amount is what we're solving for. His principal is the 11,000. It's growing for 28 years, so I better write that somewhere. And 6% per year. The next sentence, at the start of the next year, that's part B of the problem. So first I have to figure out what happens during 28 years. So stop reading, we're done for now. Okay, fidgets. What do I need to do to finish my blue section?
So what? To finish the...
My blue words, right? I'm not done with that yet.
Do something with the years.
Do something with the years, yes. If this was compounded annually, I'd be done. I'd be ready to plug things in. But it's compounded monthly. So all the time things have to be in months, not years.
This is quarter.
Quarterly is for part B. So we're not there yet.
Oh, okay. Okay.
So when we get to the next one, we're going to do the same kind of thing, but with quarterly. But we're not there yet. Part B. Okay, so what do we do with the months? So this one was divide. We're taking that 0.06 and we're sharing it among each month, right? So we're at the 0.005 again. And then I want how many months happened, because each month he gets something in the mail saying, here's your new money, right?
So it's 28 times 0.005.
No,
No, never mind.
more balanced than that.
How do you turn 28 years into months? How do you turn a year into a month?
That would be days.
So we're trying to figure out
how many months are in 28 years?
Yeah. Yeah, times 12.
336.
So now I have months, Now I'm happy. Any questions about the setup? So this is the hard part. The next step is just plugging it in. The calculator does all the work. So everyone get the same thing? Your calculators work? Your exponent keys are happy? Okay, remember the rule of 72 from the end of last time? If you have a 6% rate, how many years more or less would it take to double your money?
9.
9. 6 times 9 is 72. No, 12. 6 times 12 is 72. So 12 years. Every 12 years he should double it.
54. My bad.
Yeah. So we had 28 years. So after about 12 years, he should be at about 22,000. And at 24 years, he should be double again, so about 44,000. Now we're even past that. He's up to 58. That sounds reasonable, right? It's kind of following that rule of 72 guideline. So that's one reason we have the rule of 72, so we can sort of make sure we didn't plug something in wrong. Yeah, this seems reasonable. We're on track. Okay, part B. So this number here is his new principal. At the start of the next year, so January, year 29, he moves all that money to a different account. Now it's 23 years. And 3%. Whoops, I put this in the wrong spot. There we go. It's still true that the total amount is what we're solving for. Now our compounding is happening quarterly. So it's not true that every month he gets something in the mail. Only 4 times a year. The random numbers happen to be a little more realistic. As he's getting older, he's putting his money in a more conservative investment. He's not going to get as big a return, but it's probably safer. Okay, so stare at this. Remember how we fidgeted. What are we going to do for part B? Yeah. We take that 3%. We don't have to share it 12 times anymore. We only have to deal it out in 4 different sections. And then what will we do to the years? Yeah, times 4. Each year, 4 things will happen. So that'll be what, 80, 92 quarters? So quarters, everything is good. It matches the compounding time. So I'm happy and ready to proceed. Questions about the setup? Because again, this is the hard part. The rest is just the calculator earning its money. Okay, so 58. And we're finally done. I'm going to put a box around the answer. Okay, rule of 72. At 3% interest, how long would it take to double? 3 times what is 72? Yeah. So he invested it for 23 years. It pretty much doubled. Yeah, our ballpark is good. If we had 200,000, I would think I hit something wrong in the calculator keys, because that's too far off our estimate.
On that rule of 72, how does it deal with compounding? What's the baseline of annual, and then everything else just speeds it up a little bit more, or is it counting monthly compounding for the rule of 72? So when you say
It's based on annual, which is one
Okay.
reason it's just an estimate. You could actually get the 72 yourself if I was to lead you through a problem that had annual compounding, and you'd get to learn a little about logarithms and stuff, but it's not that exciting. Okay, so this is as hard as you can get with compound interest. It's a 2-part problem. One part uses 12s, the other part uses 4s. You have to remember to take the answer to one part and use it as the principal in the other part. Can't really get any worse than that. I guess you could make like a 3-part problem. But anyway, if you can do this, you can do any of them.
I was telling my mom that we were doing this, and I told her I would send her the link to your website because she wanted to learn.
My husband does it for a living. He said the calculator does it all the time. He doesn't even know. He can't teach me anything.
Okay, so that's our review. It's good to do more example problems in class. If you want me to do even more, I can. Should we do more compound interest? No, I'm surprised you didn't use all the pancake batter. Are you really done?
I know.
Just thoroughly like that.
You can make more if you want.
I think so. Everyone had like
Bunch. Okay, if you're happy, you're happy. The annual effective interest rate is a cute little thing. It's saying what happens if our principal is $1. If you invest $1, which you'd never actually do, then since the baseline, the principal is 1, your answer is sort of how much it's grown, right? If your result is 2, that means you've doubled it. If your result is 3, that means you've tripled it because you started with 1. So you could take something like 24% annual interest rate, but the payouts are monthly, and plug it in with a principal of 1. This one I'm going to not take my own advice and skip the blue thing just because it's so simple. No, actually I won't. Oops. I will put in the blue things.
Great.
You have an extra 0, I think. Oh.
Yes, I do. Thank you. I don't know why I keep doing that. Okay, so we had 0.24 per year and 1 year. Do the divide 12 times 12 just like before. Scooting things again. Okay.
What? Sorry. I think you started. I have to finish this. I'm so tired. I'm gonna fall asleep. I'll have a nice easier day.
Okay, so I get $1.27. So what that means is that my interest was 27 cents after a year. It's gone up 27%. So 24% with monthly power was equivalent to 27% per year. Does that make sense? To get from here to here, we just peeled off this 1. We didn't care about that. That's what we started with. So that's why, whoops, the formula has a -1 at the end. But you don't actually need this formula, because if you ever actually have to do this, you could do what we just did and say, I'll plug in 1. So that's not a new thing, really. It's just let's use compound interest formula for $1 and see what really happens in that year. And this is why the rule of 72, going back to that question, we can just have it for an annual one. Because if I wondered about a monthly rate, I could just change the monthly rate into its annual equivalent and then use the rule of 72 with that. Okay. So that's what annual effective interest rate means. It's more a vocabulary term to memorize than a math problem you would ever do in real life. But yeah, if a credit card is 24% per with monthly compounding that you're really paying 27% per year. Annually, it's effectively more. Okay, we already reviewed Rule of 72, so now we'll talk about sum of annuity due. We have a little more than 10 minutes, so we'll do an example problem, maybe 2 if we're quick, and then we'll do a bunch more on Tuesday. So, sum of annuity due is a little more realistic when talking about retirement. Compound interest is great for credit cards or things like that, but no one saves for retirement by saying, hooray, it's my 25th birthday, I'll put $11,000 in the bank and then just watch it grow for the rest of my life. Right? No, that's not how anyone does it. Most people put money in every year. Maybe you wait till after taxes, maybe you do it after Christmas time and holiday spending is done, whatever your family's habits work. But usually people will just sort of once a year figure out how much they're putting into their retirement accounts. Some people are more methodical and do it monthly, but in this class, to be simpler, we're not going to worry about that. We're only going to think that you put money in once a year, which actually makes this a friendly formula. All of that stupid fidgeting with the green times 12 divided by 12, so on, we don't have to do that anymore. This formula is always years. Everything is given to you in years. You don't have to fiddle anymore. So this formula is the also unrealistic, but slightly less unrealistic scenario where every year you put the same amount in. January 1st happens, let's put in, whatever, $2,000. And that's not, again, what happens. People save very little when they're young and don't have a big income. And then as your career gets established, you save more. But for now, we're still just sort of working on the simple formulas, the approximations. And we'll get some good lessons out of these before the end of class on Tuesday. There's a cool thing we will get to with Cindy and Clara and Chloe, but we're not there yet. So here's the sum of annuity due formula. And it looks terrible, but it's really not. I'm going to write it out in my bigger handwriting because that helps. So I start with the principal. That's not a surprise. All of these start with equals principal. And then I'm going to multiply by the 1 plus my rate. There's no per payout because, again, we're only doing annual savings.
Is that every time you put in a new principal amount?
The principal in this case is your annual deposit amount. It's a different way to use the word principal. It's not the initial amount, it's your habit of what you deposit each January 1st. So we multiply the 1 plus rate, and again, this looks like something with a parenthesis, but it'll just be like 1.05 for 5%. So we're not actually showing parentheses. Now, the next bit, on the website, it has a square bracket. And that's just a thing to help your eyes that the tradition is when using a typewriter, when using HTML, whatever, your inner parentheses are a parenthesis, then the ones outside of that are a bracket, and then if there's more outside of those, you go back to parentheses, and you go back and forth, so you can kind of see more easily how the nesting is happening. On the board, I'm not limited by the typewriter, so I'm actually going to write this with a big parenthesis, because that's even better. I have that option. 1 plus rate. Don't pay attention to this. This should be an exponent, but my copy and pasting doesn't do it. Close my big parenthesis, and then divided by rate. So it's longer than my compound interest formula, but it's easier because I still have the same things. There's not more of them. And we never have to fidget with them. Every problem will give you stuff in years. You plug it in years. Much nicer. Let's try again. Grab it all. Okay. The mistake people will make when you start doing homework over the weekend is you will make this last thing a 1+ rate. After jamming a 1 in front of your decimal twice, you're just going to be on a roll and you're going to do it again. But that's wrong. So be careful. This is just dividing by a little number. Okay, so that's the formula. Let's do an example. So someone saves $1,200 every year for retirement. So the total is what I'm solving for. We might have time to do more, so I'll grab that again. Okay. The principal is 1,200. The rate is 8%. Is it okay if I just write it as 0.08 without the ripple? The years is 45. You'll very quickly get to skipping the blue on this one, because again, you don't have to fidget ever. I'm using final and total interchangeable, please forgive me. Okay, some calculators, when they are doing order of operations, you can just type things in without worrying. When you get to this part, you'll go 1.08, hit your exponent key, do 45, and when you hit your minus key, it knows, oh, this person is done with the exponent. If they weren't, they would have put some parentheses here to say all this stuff is exponent. So as soon as you hit minus, it just knows that we're done with exponent. Other calculators won't do that. And they'll actually show a little superscript up at the top. And you'll have to hit a key to get down back onto the main row of text to get out of the exponent world. This formula, you need to put in these parentheses. If you leave them out, then the divided by 0.08 is only going to apply to that 1. Because the order of operations will do the division before the subtraction, and you'll get the wrong answer. So if you haven't used your parentheses yet, then use your parentheses. So try this now. Make sure we all get the same answer before you go home and do homework. So I'm getting about 500,000.
I thought it was too big. That's what I got.
Yep. Oops, that's not what I want. Everyone's calculator getting that?
I'll do it. I'll redo it. Don't do it.
It's odd that you were close, but not there. Because usually if you don't type something right, you get this way wrong answer. Okay, so we saw that compound interest made money grow substantially if you had a long time period and a respectable interest rate. And this is even better, right? We're putting in money again and again and again. How much of this money did she deposit? What's 45 times 1,200? 54,000. So 54,000 of this was hers, right? She felt the pain of having to write the check and put it in her account. But a lot of this was more than that 54,000. It's the interest she earns.
So, with interest, actually,
Okay, I'm going to try and rush and do one more. I'm just going to grab part of that. So somebody saves for 19 years, not nearly as long, 1,130 and 7%. So try this before you go. I know that some of you are really wanting more opportunities for doing stuff at the board for that class participation checkoff. So we'll do a whole bunch of that on Tuesday. Now that we've seen all three formulas, it'll be your turn to be up here doing examples. So tell me if you got the same or if I hit the calculator key badly. Everyone get the same as that? So
I'm messing up on, so it's just basically type it in like this, rather. So we don't, like the parentheses, I shouldn't do that first to solve for that.
it's easier just to use the parentheses. Right? So you have with parentheses. Yeah, you just left them out. So it'll be 1130 times 1.7 times start the parentheses 1.07 times 19 minus 1. Close your parentheses divided by 4.
Yeah, no way. Why didn't I know that I had that on the calculator?
Okay, congratulations. This is like sort of the end of the hardest part of the class. We have a lot more review to do. You haven't seen the interesting story of the three sisters. We haven't really gotten any practical lessons out of it yet. but those will come. So, gets more.
Do these accounts that they're putting them in, are those like those one accounts that you can't touch until like a certain amount of time?
Doesn't really matter. We can talk about different investment options later. If living in Oregon, you should know about the education accounts for kids that the state manages, and you should know about other things. But first, we're just going to do the math part, and then we'll talk about the real life part.